Great. Hello, everyone. I'm Corey. This is David here, Bernie, and we have Charlie. Our project was in collaboration with Kardia.io. So let's imagine a video game that responds to a gamer's emotional status at any point and can adapt to that, or perhaps a smartphone or smartwatch application that will notify a user of a heart irregularity. This is biometric integration, and this is what Kardia aims to solve. To make it a little easier for developers by providing a kit and a back-end analytic service. We were given initially a wearable, which is an Arduino-based Bluetooth device. And our challenge was to pump this through our network while providing rigorous time constraints. Thanks.
Since the Cardiac device is still in its early stages of development, we mocked its functionality on our Arduino device to transmit or emit realistic ECG data at rapid intervals. The data is then collected in our Swift iOS app, where it's displayed and sent to our Node.js server. From there, it is transmitted to our Python server, where various features of the incoming data are analyzed and then relayed back through the entire system, where the results can be visualized on our web and mobile app. Our primary challenge for this project was to accommodate for the extremely high data throughput of an ECG trace. Our Arduino emits data every 60 milliseconds, which needs to be read, transmitted, analyzed, and returned. Using WebSockets, we were able to facilitate these data transfers. And by the end of this presentation, we'd have sent over 2,000 data points using roughly 15,000 socket events.
On the Python analytics server, we do some number crunching in order to extract these R-wave peaks in order to get the RR intervals between them. And by analyzing these intervals, we're able to detect arrhythmias and compute heart rate. So you can see the results of this analysis in real time, side by side on our web app and our iOS app. What's happening right now is we're live streaming in data via Bluetooth from this Arduino device to a smartphone here. And if Charlie right now swaps out this device, which is mocking NSR, normal sinus rhythm, or a normal heartbeat, if he swaps it out for another device that's mocking a heartbeat that has an arrhythmia, you'll be able to see that reflected in these views once the Python server has accumulated enough data. The iOS app also saves these events in the background, so you can just leave the app running in the background on your phone and then come back at any time to review them. So it turns out that arrhythmia analysis is just the tip of the iceberg. Like we alluded to before, it's possible to infer a lot of interesting things from ECG data. For example, the user's emotional state, as well as their risk for cardiac episode. But our proof of concept work here lays the foundation for Kardia's analytics platform, and together with our iOS app, encourages developer creativity by making this hard stuff easy. Thanks.